Good morning, everyone. Today we're talking about square roots. So let's start with this first question. What number multiplied by itself equals 25? Well, we all hopefully know that 5 times 5 equals 25. But is there another number that multiplied by itself equals positive 25? Well, there is. Hopefully you all answered negative 5. A lot of times we forget about that, but a negative times another negative becomes positive. So negative 5 times negative 5 is also 25. This number is called the square root. A square root is the number, in this case the 5, when it multiplies by itself, gets me to the other number, or the original number. So the square root of 25 is 5, and also negative 5. So every positive number has both a positive and a negative square root, just like we showed. So 0, which you think about, doesn't really have a positive or negative sign, only has one square root, which is the number 0. It's not that it's undefined. We can definitely give an answer to it. It's 0, because 0 times 0 is 0. So like the number 25 up above is when I have the square root would be 5, because 5 times 5 is 25, and also negative 5, because negative 5 times negative 5 is also positive 25. So the next number, vocabulary we want to talk about here is a perfect square. So we're going to deal mostly in perfect squares this year. Perfect squares are numbers that have integers as our square roots. So there is no decimals. We're not looking at things that come out as 2.4 as the square root. Anything that you're going to look at in that kind of a situation, you'd be just using a calculator. We're going to be talking about more of our perfect squares. They are looking at things that come out as a 1 or a 2 or a 3. So I'm just going to show you a whole bunch of them in a moment, and if you just want to copy these down, it would probably be a good thing because it's really helpful to do this. So there I've just written the perfect squares all the way up until 196. Obviously, it would be good to know more than that just because it helps to move along through problems when you don't necessarily need to use the calculator. But all of these numbers, if you just go through them, and we'll just kind of talk through a few of them right now. If I was to just look at the first one, 1 is a perfect square because when I take the square root of 1, the answer is 1. 2 is not a perfect square because the square root of 2 is someplace in between 1 and 2. 3 is not a perfect square because if I take the square root of it, it's also, again, between 1 and 2. But the number 4, when I take the square root, 2 times 2 is 4. So 4 is a perfect square because the square root is a 2. Then again, I jump to 9. 3 times 3 is 9, so 9 is a perfect square. 16 is a perfect square. The square root is 4. 25, as we just saw, is 5. The square root of 36 is 6. 49 is 7. 64 is 8. 81 is 9. 100 is 10. 11 for the 121, and all the way to the top. So a perfect square are these numbers that when I take the square roots, I get an integer answer. So on to the next part. So the next one says, here's a problem. Find the 2 square roots of 49. Well, we just saw a moment ago that 49 is one of these perfect squares right here. So basically, I just want to make sure I write the answer is 7. 7 times 7 is 49. But also, don't forget the negative 7. If you're just given a sentence and it says find the square roots, we want to make sure that we include them both because they both do end up giving me 49. Next, we want to talk about this symbol here. It looks like a little bit of a division symbol with a little tail on the front. So the symbol, which is that little note that we see, this is called a radical. This is the radical sign. It is used to represent the positive square root. Important to note this. So here's an example. If I was to say to you, what is the square root of 64? So just seeing that symbol, up above we said that there's two different answers. There's the negative and the positive. If I just see the symbol, and this is the universal symbol you'll see on your computers and your calculators, the square root symbol, that would tell me I only want 8. So the square root with that square root symbol of 64 is just the 8. Where up above, when we said find the square roots, there's no symbols there, we're just asking, and we want to include both. So with that same idea, when I see this next one, I see the little negative out in front. That would be telling me I want to have the negative square root. So for example, if I saw this, that reads as, what is the negative square root of 36? Which would mean it's not 6 this time. We would only want the negative 6 for my answer. Okay? Sometimes we're also going to see this, and I'm going to have to write this over to the right-hand side. Sometimes we also see this symbol, this little plus and minus on top of each other, and what do you think that tells me? Right, that basically means that if I wanted the plus or minus square root of 81, now we're back to wanting both positive and negative 9. So we kind of have those 3 different symbols that you'll see throughout these different things. The only other thing I do want to point out is another vocabulary word, the number that we see under the radical sign. So in this case, we would be looking at the 64. Here we'd see the 36. Here we're seeing the 81. This is called the radicand. That is the number underneath the radical sign. So let's just go through a bunch of examples here. Let's just see what we can come up with. So the first one, we have, what is the square root of 36? Well, again, we saw that in the up above. When we see it just in words, we want to then say we don't know if it wants the negative or the positive, so we definitely have to include both. We want to make sure that it's including both because it didn't specify one or the other. The second one, though, the square root of 64 with the negative in the front, means we want only the negative square root of 64. Square root of 64 is a perfect square, so that would mean my answer is negative 8. Now here's one that's a little bit tricky. People get confused on this one, but really what's going to happen is we're going to look at this square root of 4/25. Now if I could reduce this fraction and maybe look at it a little bit and see if I can go further, that's great. But wanted you to notice a couple of things. Number one, 4, there's one of your perfect squares. 25, there's another one of your perfect squares. So what we're going to do is we're going to use a property that you'll learn more about in algebra next year and break this fraction into 2 parts. We're going to take care of the numerator separate from the denominator. And again, because I see those perfect squares, this makes it a little bit easier to kind of see. So if I focus on the numerator, what is the square root of 4? Well, 2 times 2 is 4, so the square root of 4 is 2. What is the square root of 25? Well, the square root of 25 is 5 times 5. There's your answer. So it's as simple as that. By taking care of the numerator and the denominator, we get to 2/5. So it looks challenging at first, not as challenging, but it's definitely something that we have to just get practice with. Take care of the numerator first, then look at the denominator. If you can't reduce the fraction, if you can reduce the fraction to find some other perfect squares, we might see one of those coming up soon. Number 4 and 5 are a little bit trickier. I kind of wish they didn't really involve these right now. I think a lot of times I might just grab the calculator with the decimals. But again, I do see an 81 inside this radicand, even though it's a 0.81. So I know that the square root of 81 is 9. One of the problems with this is a lot of times we want to jump to that it is 0.09. Well, if you think about it, when you multiply 2 decimals together, you're adding up the decimal points. So because there are 2 decimals right here, I got to remember when I multiply them together, I'm going to actually get the addition of my decimal places. So 9 times 9 is 81, right? And I would move my decimal over 2 places to get that number. So sometimes I think this is one that a lot of people will put 0.09, but it's actually 0.9. So 0.9 is my answer there. The next one, again, looks a little bit tricky because of the fact that it is 12.25. And this last one is definitely not one that I would ever ask you to do in a calculator. I probably wouldn't even do it in a calculator, but let's just look at it. It is 12.25, which is not a perfect square, but 1,225 is a perfect square. It's actually 35. We see the little plus minus out in front, which would tell me that we want both the positive and the negative. So our answer is going to be positive and negative. 35 times 35 is 1225. Now again, we just mentioned on the previous one that the decimals are going to keep adding up as you're multiplying. So this becomes 3.5. And again, as a quick little estimate, well, what is 3 times 3? 3 times 3 is 9. It's a little bit less than 12. What's 4 times 4? 16, which is a little bit more than 12. So 3.5 kind of makes sense. If I had somehow put 0.35 as my answer, it wouldn't have made sense as a quick little check. So now we want to evaluate some expressions that have the square root symbol within them. So remember, when we're talking about solving things, we need to use our correct order of operations. So we're going to continue to think about GEMDAS. Remember, G is groupings, E is exponents. Exponents are the things that we talked about in the last chapter with the little exponents, the squares, the fifths, and all the rest of that for the power. But it's also our square roots. Every time I do the square root symbol, that is considered an exponent. So keep that in mind. Then we also have the multiplication. We have the division, addition, and subtractions, which we know how to get through the order of operations. So this first one, 5 times the square root of 36 plus 7. So the first thing that has to be dealt with is the square root of 36. You can't multiply 5 times that first before we get the square root taken care of. Now again, notice in the notation, it doesn't allow for the negative 6. It's just talking about positive 6. So once I bring down that first step, I now see multiplication and addition, which means we do multiplication to get the 30, and then we can do our last step to get 37. Now on the second one, we have one of those square roots of a fraction, which can be a little bit confusing. Now this time, when I said in the previous examples, if I see the perfect squares, I can just do these as 2 separate pieces. 18, though, is not a perfect square. 16 is, 25 is, but not 18. 2 is also not a perfect square. 1 is, and then 4 is. But as a fraction, what does 18 over 2 become? If I just take care of that first, 18 over 2, isn't that the same thing as 9? So because it's 9, that is now a perfect square. So again, the perfect square gets dealt with first. Square root of 9, we only want the positive in this case. And my answer is just going to become 3 1/4. This next one kind of creates the big idea of this whole thing we're about to hit. There's a couple ways that I can do this. So when I first look at this, I got to go inside the parentheses, right? Because we always say groupings come first. So what is the square root of 81? Square root of 81 is 9. Now I can take care of the outside parts. The outside part says 9 squared, which remember is not 9 times 2. It's 9 times itself, which gives me the answer of 81. I want you to notice what I just did there. We have this 81 in the radicand. We take the square root of it, and then we square it. And look at what we end up with. So by taking the square root of a number and then squaring it, you basically get right back where you started from, which is really important to notice right here. So when I find the square root of a number and then square it, I'm basically undoing the other operation. So basically, they are an inverse operation. So squares and square roots undo each other. So very similar to adding and subtracting, multiplying and dividing, we now have squares and square roots. So we're going to use that to take a look at these 2 problems. Now we have not just expressions, but we have an equation that we're solving using the square root. So the first one, x squared equals 81. So to solve an equation, we've always done the little line down the middle so we can take care of the left side and the right side. I need to get the x all by itself. So to get the x by itself, we have to undo the operation that we see. The operation that I see right now is x squared. So what we just talked about was the opposite of squaring is the square root. So I'm going to take the square root of both sides. So if I take the square root of x squared, it undoes the square to give me the x. And if I take the square root of 81, I get 9. My answer is x equals 9. On the next one, we have 3a squared. Now, a couple of things are happening here. So remember in the last chapter, the exponent 2 only affects what it is right next to. This is, you got to be careful here because this is only affecting the a. There aren't any parentheses here that would include the 3. So this square is only going to the a. So you got to keep that in mind. So when I look at my inverse operations, the exponents are going to come after multiplying and dividing. So my very first move here is to divide because I see 3 times a squared. So I'm going to first move the 3 to the other side. That's going to cancel the 3's to get a squared and a 16. Now again, I need to get a by itself. So I take the square root to undo the a squared. And there I get the square root of 16, which is 4. A equals 4 is the correct answer. And lastly, we want to see a word problem here to see how this might work in a situation. We have the area of the crop circle is 45,216 square feet. Remember, area is in square feet. And we want to know what is the radius of the crop circle. So that's what we're looking for eventually. So what we know first is the circle. The area of a circle is a equals pi r squared. That's the area formula for a circle. And we want to plug in what do we have and what don't we have to figure out what we need. What we're looking for eventually here is radius, so we got to keep that in mind. So what we have so far, we have the area. The area is 45,216, so we can plug that in. They are telling us 3.14 is what we want to use, and we don't have the radius yet. And so here we have 3.14 times r squared on the right-hand side. Again, we're trying to solve for r. So we need to start moving with our inverse operations. Well, again, exponents are going to come after 3.14 when I use my opposite operations. So my first move here is to use 3.14 and divide. That's going to remove the 3.14 on the right, leaving me with just r squared. On the left-hand side, when I divide 45,216 by 3.14, I get 14,400. So now I need to get r by itself. So to do that, we do that inverse operation. Take the square root. That's going to give me the square root of r squared becomes just r. Then the square root of 14,400, definitely use a calculator. This is not something that we would expect you to know how to get right off the top of your head. It is actually a perfect square, and it comes out to 120. So because it's a 120, now I just have to answer the question, what is the radius of the crop circle? So we know from the beginning that it was in square feet. So basically I just have to tag on my little label. It is 120 feet. And that would be the answer to the radius of the crop circle. Hopefully this goes pretty smoothly and easily. If you have any kind of questions, let me know. We'll be covering this pretty quickly because usually this is something that we can get pretty easily. If you don't, though, please let me know so we can go over it. Hope everyone has a great day.